All right, thank you guys for joining me in this bonus video. Let's get started by factoring this rational equation. Okay, so when we factor this equation out, we're going to 3x, and we're going to GCF this, get that x squared out, x minus 1, equal to x minus 2 all over x minus 1, x minus 2. All right, so hold up. So we've been working with simplifying rational expressions for a while, so a lot of you guys are probably noticing that we can cancel out these two. Well, that's a good observation, but we can't do that before we figure out what our domain is. Because if we cancel those two out, it will affect our domain. All right, so over here to our left, x cannot equal 0 or 1, and over here, x cannot equal 1 or 2. And so our domain is going to be x cannot equal 0, 1, 2. All right, now that we figured out what our domain was, we can now cross these out. All right, and so after that, we've done domain, we can look at the least common multiple. And so here, our denominator is just going to be x minus 1, and x minus 1 is a multiple of x squared times x minus 1, so this is going to be our multiple. We don't have to worry about our x minus 2 here because we've got rid of them already. Okay, so let's go ahead and multiply that through. So we're going to get x squared times x minus 1, and all that's multiplied by 3x over x squared times x minus 1 is equal to x squared times x minus 1 times 1 over x minus 1. Okay, we need to go ahead and cancel some things out. This x minus 1 and this x minus 1, and all of these guys. And so we're left with 3x is equal to x squared. All right, so we set this equal to 0. So we get x squared minus 3x is equal to 0. We're going to take the GCF and we get x minus 3 equal to 0. And so x is going to be equal to 0, or x is going to be equal to 3. Now we come up with two solutions. So now we just have to check for extraneous solutions. And it's pretty clear to see that x equals 0 cannot be a solution, because if it is, we'll end up getting a defined answer, and since 0 is not part of our domain, it can't work. 3, however, is within our domain, and x can equal 3, so we can use x equals 3. Okay. All right, so let's move on to the second example. And like you guys guessed, our first step's going to be factoring. So it looks like we can't factor this first denominator, but the second denominator we can definitely factor. So let's go ahead and do that. And we're going to get 5 over 2x plus 1 plus 8 over 2x plus 1 times x minus 2 is equal to x over x minus 2. Okay, cool. So we factored. Now let's state what our domain is. So our domain here, we're going to have x cannot equal 1/2 and x cannot equal 2. Cool. And other than that, x exists for all reals. All right, domain, easy, done. Let's move on to the LCM, least common multiple in the denominators. All right, so we can tell that 2x plus 1 is a multiple of 2x plus 1 times x minus 2. And the same goes for x minus 2. And we know this guy right here is a multiple of itself. So our LCM is going to be 2x plus 1 times x minus 2. All right, now let's multiply both sides by LCM. All right, so hold up. Okay. 2x plus 1 times x minus 2 is equal to, oh, sorry, got a little ahead of myself, times 5 over 2x plus 1 plus 8 over 2x plus 1 times x minus 2 is equal to 2x plus 1 times x minus 2 times x all over x minus 2. All right, cool. Right here, we can get rid of our x minus 2's. And over on this other side, we're going to have to multiply this whole guy to the 5 and into the 8 over 2x plus 1 times x minus 2. All right, so when we do that, we will get 5 times x minus 2 plus 8 is equal to 2x plus 1 times x. Okay, so now let's solve. I want to go ahead and pause the video, do some algebra, and I'll come back with the solution. All right, so I haven't came up with the solution yet, but I wanted to stop here because I feel like this is a good stopping point. Remember how to solve for x. And so here, stops right here. We can factor out this 2. So we'll get 2 times x squared minus 2x plus 1. And so we can factor this down to 2 times x minus 1 times x minus 1. So x is equal to 1. All right. X and 1 is in our, or 1 is in our domain, so x can equal 1. All right. So let's move on to our last example. So here you guys should be starting to get the rhythm of things and how, what step we do first. And of course, that's factoring. All right, and so when we factor, looks like the only thing we can factor is this. So let's go ahead and rewrite it. 6 over x plus 3 plus x over x minus 3 is equal to 4 over x plus 3 times x minus 3. All right. Now go to our domain, and here we can see that x cannot equal -3 or 3. And the same goes for these guys over here. And so this will be our final domain. And then we move on to our least common multiple within our denominators. And so it's easy to see that x plus 3 is a multiple of this guy, and x minus 3 is a multiple of this guy. So here is our least common multiple. All right, so we've got that. So I'd multiply by the least common multiple. So we're going to get x plus 3, x minus 3, and all that is going to be multiplied by, hold on, Make some room. 6 over x plus 3 plus x over x minus 3 is equal to x plus 3, x minus 3 times 4 all over x plus 3, x minus 3. All right, and right away, you see that these guys cancel out. And so let's go ahead, multiply everything on the left-hand side of our equation in. And when we do that, we're going to get 6 times x minus 3 plus x times x plus 3 is equal to 4. All right, I'm going to go ahead and pause the video here again. This is just some algebra, and I'll come back with the solutions. All right, so after we do some factoring, and by factoring I mean we'd factor this expression after working the algebra, we'd end up getting x plus 11 times x minus 2. And so our solution is going to be x is equal to negative 11 and 2. And since negative 11 and 2 are within our domain, this checks off. And so that is our final video. I hope that was enough examples for you guys. Remember, if you have any more questions, don't be afraid to ask me or Mr. Callahan. We're here to help. So, yeah, thank you for watching.